This first video in my series of 2 videos is going to be composed of the theory of steel, and it's going to be composed of a totally impractical explanation of how you would make a knife if you were really serious about it and you wanted something that was quality to come out on the other end. And we're going to start with a little bit of history. So for some period of time, thousands of years, maybe longer depending on who you actually want to believe, our species has been capable of taking stones that were high in iron and copper and other metals, and we've been able to take those and we've been able to extract the ore from them. Now, the most practical and effective way to do this was established a couple thousand years ago in the Middle East. Some of the best ways were in the Damascus area. Now, this general sect of metallurgy would be referred to as the making of crucible steel. Now, a brief explanation of crucible steel. This is essentially a crucible. Now, a crucible is a ceramic container. Ceramic was chosen because ceramic can withstand an incredible amount of heat and maintain its shape. So a crucible is a ceramic container with a lid. What they would do is they would place ore inside the crucible, and they would take the lid and they would seal it with wax, and they'd put the lid on and they would place this in the forge, and they would proceed to heat this for an extended period of time. Now what happens is what you put in settles or bonds depending on what you put in. So if you put in really impure substances, what you're going to have happen is this. Do you remember the first several years science classes at school where they had you take some sort of container and you put water and a couple different oils and some vaguely noxious substances in there and they all settled? Right? So you had different layers. The same thing happens to your metals inside your crucible. What you're going to have happen is you're going to have your heavier metals settle to the bottom, and you're going to have other metals in the middle, and you're going to have odd substances like carbon and glass on the top, depending on what you put in. Then, simply in order to get it out, you smash your crucible. It's simply a ceramic, so it's not particularly sturdy. You smash it, and then you have an ingot of pure materials. Now you can do some really cool things with crucible steel. If you take pure iron and you take carbon and you mix them together in a crucible and you change the temperature periodically, you can get Damascus steel. Now Damascus steel is steel with a watery pattern in it, composed of layers, wavy layers of high carbon and low carbon steel. What's interesting about Damascus steel is that it's super plastic. Basically it bends and it will be able to retain its original shape very well. So great for making knives and swords. Good luck making it though, because you basically can't do it unless you're an expert, because it's that hard. Very rigorous, very difficult, and sometimes I assume it's like pottery where you do everything right and it just doesn't come out. So that's your brief history lesson. Now this is applicable because what you're going to have is you're going to have spring steel from some vehicle that Brother Davis dredged up from somewhere. Spring steel is not pure steel. Spring steel is a set of different materials. There's probably going to be some molybdenum, maybe some other things in there like coppers or slightly more flexible metals so that it will be able to retain its shape when it's in the form of a spring. And if you really want to be able to get a pure iron or a really pure steel out of that, you're going to have to put that in a crucible. And you're going to have to melt it, and you're going to end up with an ingot at the end. Now I'll explain this process, and I have a little picture behind me of how you're going to build a forge if you're interested. So here it goes. You asked me how I would melt metal, and this is your answer. You're going to need a shovel. You're going to need some leaf blowers, some cinder blocks, some bricks, and you're going to need a bunch of coal. Preferably coal and not charcoal. I have charcoal written here. Actual coal is going to be able to bring you to higher temperatures because it's a more pure substance. So what you want to do is you want to dig a pit, maybe 8 inches deep, and 1 foot by 1 foot. And off of that you're going to dig a channel, and you're going to place cinder blocks in that channel facing so that the holes in the cinder block go towards your pit. You're going to fill your pit with charcoal or coal, and on top you're just going to make a pyramid of bricks. And then at the end of your channel of cinder blocks, since each cinder block has 2 channels in it, you're going to take 2 leaf blowers and you're going to stick them in the end of that channel. What that's going to do is that's going to provide a lot of pressure and a lot of oxygen to your forge, and you might actually be able to, with a sustained blower, bring this up to about 10,000 degrees, which would be pretty impressive. The bricks on the top are purely to prevent the release of heat, and they're to increase the pressure in your forge. It's also to prevent nincompoops from falling into it. You have some of those in your quarry. Make sure that when you make your pyramid of bricks, you leave an opening so that the pit actually extends further than the brick, so that you have an opening that you can insert things into your forge. Now here's how this works. I'm going to give you a practical and a less practical solution. Your less practical solution is your crucible. You're going to take your spring, chop it up into chunks, put it inside a crucible. You're going to have to buy a crucible, by the way, because making one would be very difficult. So you're going to put it in the crucible, and you're going to stick it inside your forge. And at the end you're going to have some very nice pure steels, and if you do it properly you could even end up with high carbon and low carbon steel, which would be very nice. But at the end, the issue associated with that is you're going to have a lump of steel, which means that this is going to be your best friend for the next several weeks. Because you're going to have to pound it into the shape of a knife, and when it comes out shaped vaguely like a potato, you have a long ways to go to turn it into a knife. One of the reasons that I said this was highly impractical is because of this. This is probably about a 4 or a 5 pound sledgehammer, and some of the people in your quorum will be physically incapable of swinging this for 10 hours. They won't be able to do it. In case you do decide to go with this option, the proper form for using one of these is to rotate at the shoulder as opposed to the elbow. This is not a particularly effective blow for forging something, but this is, for future reference. Another more practical method is that you could take the impure steel from the spring and you could make a billet. A billet is basically a section of your spring. I don't know, maybe 8 inches by 2 inches, and you're going to attach it to a piece of rebar, and you're just going to poke it into your charcoal pit, and that's going to bring it up to some very high temperatures, and you're going to be able to forge it on an anvil from there. Impractical, fun, cattle prod on a stick, basically, kind of like a branding iron at this point. For future reference, the brighter your steel glows, the closer it is to a liquid, which means that if you pull it out and it's white hot and you hit it on an anvil, it's going to kind of splat, and that's not particularly effective. So I'm going to be issuing another video that's going to give you a nice, concise way to actually do this that will cater to the lowest common denominator and give you some probably nice and not particularly honorably made knives.